Welcome to Diamond Solutions for Mathematics. Today we are discussing 10th standard mathematics topic arithmetic progression. An application question related to arithmetic progression is here. How many three-digit numbers are divisible by 7? That is the question here. How many three-digit numbers are divisible by 7? We know that the smallest three-digit number is 100 and the largest three-digit number is 999. First of all, we can trace the smallest three-digit number. The smallest three-digit number divisible by 7 equals 100 divided by 7. When we divide 100 by 7, we get 15 the quotient and the remainder positive 5. Positive 5. But this positive 5 is excess here in the 100. That 100, how it comes? 100 divided by 7. First of all, 10 divided 7. 1 times 7, 3, 30. 7, 30 up to 7 fours are 28. But I go to the next multiple of 7. 7 fives are 35. Therefore, plus 35 minus 30 and here gives positive 5. That is, if 5 is excess, that 5 when added to 100, it is divisible by 7 and gets 50. Therefore, the smallest three-digit number from 700 to 999 from 100. The number that is divisible by 7 after 100 is 100 plus this remainder 5, that is 105. 105 is divisible by 7. Thus we can trace the first number. This is the procedure to find out the next number divisible by 7. For that we can do any question like this by dividing in this way. 100, I am once more repeating, 100 divided by 7, 1 times 7, 30, 3 0 and 7. Next multiple after 30 is 35. Therefore, 7 5s are 35. Plus 35 minus 30 gives plus 5. That plus 5 when added to 100 this divisor, we get a dividend, we get 100 plus 5, 105. 105 is the next number after 100 which is divisible by 7. The largest three-digit number divisible by 7, next we can find. That is 999 divided by 7. 7 ones 4, 7, the remainder 2, 29, 7 fours are 28, remainder 1, 19, 7 twos are 14, remainder 5. That 5 when subtracted from 999, we get the next to lower 999 number divisible by 7, that is 994. The largest three-digit number divisible by 7 equals 999 minus 5, remainder 5 gives 994. Thus we traced the lowest three-digit number divisible by 7 and the largest three-digit number divisible by 7. Then we can form the AP 105, 105 plus 7, 112, 112 plus 7, 190, 190 plus 7, 126, and so on. 987, 994 is the largest three-digit number divisible by 7. This form an AP. Why? Because T2 minus T1 equals T3 minus T2 equals 7. Therefore, this sequence is an arithmetic progression with the common difference 7. Let the number of these numbers, the total number of numbers in this sequence is n, we can consider. Therefore, a plus n minus 1 into d equals a n. That is nth term. Nth term is defined 994. Therefore, a 105. N we have to find out. Plus n minus 1 into d. T2 minus T1 equals T3 minus T2 equals 7. Therefore, 105 plus n minus 1 into 7 equals 994. 7 is the common difference. Number of numbers, terms in this AP is n. We have to find out that n. Therefore, n minus 1 into 7 equals 994 minus 105. That is n minus 1 into 7 equals 994 minus 105 equals 887. Therefore, n minus 1 equals 887 by 7, which defines 127. N minus 1 equals 127. Therefore, n equals 127 plus 1 equals 128. Thus, n is defined as 128. N means the number of numbers in this AP sequence. That is 128. That is the number divisible by 7, three-digit numbers divisible by 7 equals 128. That is 128 three-digit numbers are divisible by 7. We can define like this. Hence, there are 128 three-digit numbers divisible by 7. Subscribe Diamond Solutions for Mathematics for easy and tough questions.